Howdy Hacksters! Alex Glow here. Last week we started counting down our top 10 most viewed Hackster Café interviews from 2021, with my favorite excerpts from each one. Now let's jump into part 2. If you like what you see, be sure to check out the full interviews linked below, and of course, subscribe for more. You make them all yourself?
Yeah, the only part that is made by the external factory is the circuit board, the logic board, that contains all the electronics on the button. But otherwise, every aspect is done manually. What I love about the process of making these is that it got like the maker spirit. Everything apart from the Prusa's excellent 3D printer and the sorting station is like custom made and custom designed for the flower itself. So we got different jigs for soldering. We got the custom made CNC machine to mill the flower pots and a lot of various stuff to do it. We also have my latest creation,
Whoa!
wire cutter machine to simplify the labor work. You know, this is the spool of wire, and you have to make it into this. There is 27 different lengths of wires on each flower. So it's absolutely waste of time to cut them by hand. So in the spirit of a maker, I've designed and made this 3D printed wire cutter machine, which do the job for me. And that's on the end, there is the cutting head. So there is the line where the wire gets straightened. There is the feeder, like the feeder motor that feeds the wire into the cutter. And there is this cutting mechanism that does the wire. So, that's the dream. And I want to continue to do the stuff like that. So to innovate and to create stuff on my own. And that's what I love about this job.
As to how that influences my creative process, it's really spontaneous. I mean, I do try to plan things, and I had to. The longest I've ever spent on a project was my wearables line, Bright Wearables, where I created a line of circuit boards that fit into bags and backpacks built around the microbit. And it started off, as my ideas often do, as kind of a kids project. I actually get a lot of inspiration from kids projects. So I said, because the microbit is such a cool, fun little programmable microcontroller, I'm like, and there are already existing LED add-on boards. And I'm like, well, what if we put that in a bag or a backpack? And I started with a lace-up kit. The idea was a lace-up kit that kids actually at my summer camp could put together. And then I'm like, well, wait a second. What if they wanted to take the circuit board out and then put it back in? I'm like, how could we make that detachable easily rather than lacing it in? And then I came up with the idea of, I don't know if you can see, there's snaps on the circuit board and corresponding snaps inside the bag. Yeah, thanks. So I mean, this is one example of it just kind of evolved from there, and I kept taking the idea to the next level, and I had to focus on this one for a long time. It took me really kind of a year of designing and all kinds of things. I had to learn how to source products from China, things like that. So that was probably the longest I've ever spent on a single process. More often, I'll see something, and just usually it starts out with, I wonder if this is possible.
Do you have tips for people who might be trying to build their own relationships with suppliers?
Yeah. The biggest thing is don't be in a hurry. The more time pressure you're under, the more likely you'll make a decision just based on time and not actually on quality or cost or anything like that. For example, when we were figuring out a source for the audio jacks that we use for our modules, which we use a lot of them because that's Eurorack, right? It has a bunch of little jacks on it.
Yeah.
So, we need thousands to produce our stuff. And, I found a manufacturer really fast. And, if I had been under a time crunch, I would have gone with them. But I actually took the time to get samples from them and samples from another manufacturer, and comparing them, I was like, holy cow. You wouldn't know it if you only had one of them, but there is a huge, vast difference in quality. And yeah, like not being in a rush, like really kind of helped me out early on, just because like I was able to, take the time to get samples from 20 different suppliers for my cables. And I was able to take the time to make sure that like I'm sourcing parts that are actually high quality and not, super cheap. Like, oh my God, the jacks. I think I still have the samples for that manufacturer somewhere, but like the metal on them was like so soft that you could only screw the nut on like a couple of times before the threads were just gone.
Oh no.
And like if you just took a superficial look at it, you'd be like, oh, that's fine. But like as soon as you start like actually using it, you're like, oh no, that's not fine.
Your Hackaday Prize winning project, the DLT1, which stands for what?
The damn Linux tablet. Wow. Right, so that was in 2019. So I took to making not just a tablet, but like a kind of like a standard for mobile devices to bring this modularity to mobile devices that you have with computers. You have like these PCI Express slots where you can plug a GPU and then you can add a hard drive, and there's some you can change your device. And so here this is the unit with the screen, and this is basically the empty inside. And the idea was to be able to at least change peripherals or like connectors. So like maybe you want a USB-A connector, so you can place a USB-A connector, or in the future it could be a USB-C connector. But it's still USB. Like why should you like throw it out? Or you had a micro USB and you want to upgrade to USB-C. Like there's no reason to throw out the device. You could change the connector in theory. Yeah. So that was like the core idea. So we can take out these little pieces here and then place connectors here.
How do those attach together?
Then they have like these face plates. Just screws. So very like you only need a screwdriver to disassemble this. So this is the motherboard. This is a Jetson Nano. That's what I worked with back then. And the idea was to define like default pinouts for these flat flex connectors for like HDMI, USB, embedded display port, Ethernet, all that kind of stuff. So I can take this HDMI and plug this into the HDMI port over here.
That's so cool.
And you could, maybe you want to upgrade the motherboard. You don't have to throw away, everything else. You just have to upgrade the motherboard and everything else will stay the same. Like it's, I think, much more. It gives you much more power over your device, even if you're not a hardware hacker.
We make this thing called the OpenMV Cam. Now we finally upgraded to the STM32H7, and it's been selling pretty well, actually. So interestingly enough, what we actually have been doing is something that I think a lot of people don't think about, but optimization. It's actually the case that we left a lot of performance on the table with our current processor. And just by getting into the data sheets and utilizing things like the DMA controllers and the fact that the processor can do a little bit of SIMD magic, which allows you to double pump operations, more or less getting you 2x per pixels processed per clock, and then also just improving the algorithms. We've actually been able to dramatically improve the performance of most of our firmware by more than 2.5x since we started working on this processor.
Wow.
So it is like the same hardware per se. We've been unlocking a lot of features that dramatically improve the speed and processing power of what we're actually able to do. An example, we just finished optimizing something called JPEG compression. This processor has a JPEG compression core in silicon. But normally the C code that was given to us is for the development environment that's provided by ST Microelectronics. That default C code feeds the JPEG processor with, it manually has the main CPU writing a byte at a time, image pixels to the JPEG core. And when we looked at what this code was doing, we realized that the main processor was spending most of its time sitting there writing data to the JPEG core and not actually doing real work. But ST had developed in a direct memory access path where you could just pass a buffer, a pointer to a piece of memory, a memory location, and DMA then would turn on and feed the JPEG core without you having to manually do this. And so once we finished, optimizing some code lately, and I just got we're just getting that merged in right now. This actually boosts the JPEG compression performance by 2.5x. And yeah. So it's literally like, we are, I think when we started so far through the optimization process, we have improved the performance of that original code by about 5 times now. And so if you think about it, it's like we've gotten, just through these optimization processes, we are effectively getting a new H7 that's faster and faster every couple of months as we release new firmware updates.
Wow. Thanks for coming with us into 2022. Happy New Year, and hack on.